Hello everyone. Thank you for coming here tonight, because it's night out there in this bad weather, so I very appreciate it. My talk will be about face detection in browsers, as you may guess. But before that, let me properly introduce myself. So my name is Mirek Ciastek. I'm front-end developer here at SwingDev. I have at least 4 years of professional experience. I did many applications using different frameworks, but what's most important here is that I really love to discover new APIs that we can use in browsers. And I think of myself as a web enthusiast. And I'm sure that I'm not the only one here in this room. And why is that? Because front-end development is great. So in browser, we can, it's really great. In browsers, we can, for example, do a VR, AR games. We can even use databases on the front end using the IndexedDB API. And also, we can mine cryptocurrencies. So this may be something that you are familiar with, that add with proposing you to use your browser to mine some crypto, but still we have plenty of possibilities of what we can do with our browsers. And 2 of them are face detection and face recognition. And at the first sight, they may seem to be very similar, but they are very different. So the face detection is first step in face recognition process. We simply take our picture. We try to find in this picture a face, and that's our job, right? We have the face, and that's all, right? But face recognition goes 1 step further, and it allows us to match a specific face with a specific person, right? So for us, for humans, it's a very simple task, but for computers, it means hours of learning. So that's why, for example, for face recognition, we use machine learning. But even if the face recognition is not that exciting as the face detection is not that exciting as face recognition, it has an important place. It takes an important place in our market, in software development also. So the first example is a well-known Snapchat filters. So the doggy face and the rainbow face are an example of face detection. And even recently, Snapchat introduced a cat's face detection. So using Snapchat, you can put a sticker on the face of your cat. So imagine if you could put a doggy. I'm not sure if it's possible. I would try it, and definitely. But imagine if you can put a doggy face on your cat. That's mind blow, right? And the next is Animoji. That's the great innovation introduced by Apple, which definitely pushed all consumers to buy a new iPhone X, right? That's the breathtaking technology. And lastly, our cameras. Our modern cameras application has face detection built in. I'm not much of a photographer, so I didn't know it until now, but I tested it on my phone, and it's really recognized faces. Detects faces, sorry. So how it works? The concept is very simple. We just get the input, so our image, we normalize it, analyze it, and we get the result. And I wish that it's that simple, because face detection to be To be specific, the face detection is very complex. So most of the algorithms use most of these 4 methods of detecting the face, and even using these methods, they fail sometimes. So you need to remember that bad face detection can cause a heart attack of your user, right? Because you will end up with ghost faces, like in this example. But this talk is about face detection in JavaScript. So how we can do it in JavaScript? I decided to compare 4 methods of face detection in JavaScript on the front end. So the first one is Node.js and OpenCV. And OpenCV is one of the most popular computer vision library that we can use. It's open source. That's probably why it's so popular, but it's also good. So how we can use it? Because OpenCV was written in C++. So how we can use it if we know only JavaScript? We can use any library for Node.js that has bindings for OpenCV. So here I used OpenCV for Node.js. That's one of the latest libraries for this technology, and it uses OpenCV in version 3. It also to detect face, we can use a Ciastek classifier, which is a renamed Viola-Jones classifier, known from the previous version of OpenCV. And this classifier uses a hard features which I will talk a bit later. And also to get the image, to detect the face in our webcam stream, we can pass it. We can stream it by WebSockets. But before that, let's talk about hard features. The hard features are features or characteristics that helps us to find a specific part of the face. So, for example, in normal light conditions, the eye is probably darker than the area of the cheek. So we make this feature and we try to find it in our image of our face. When we find it, we know that that's the area of eye, and we have all series of features which helps us to detect the face. And here's the code how we can do it. So here's the code that we write on the backend side, because in this approach we need 2 applications, one the API, the backend application, and the other one the front end. So here we have receive the encoded in base64 image. We process it using the Ciastek classifier, and we send back the result. And on the front end, we can get this result and just for example draw a rectangle in a place where the face is. The next approach is Tracking.js, and Tracking.js use also the Viola-Jones classifier, like in OpenCV. It also uses the hard features, and comparing to the previous approach, the previous method, it's entirely the front-end solution. So we don't need to build any second application. We don't need to connect to the backend to detect the face. And how we can do it here? So we define what classifier we want to use. It will be the Viola-Jones, and it will be classifier for the face. And we detect the face right here, and then we grab the results, and we can draw the rectangle in a place of the face. So I mentioned about cats in Snapchat application, and if you like the idea of detecting cats' faces, And I think that the next library will definitely help you with, because face-api.js uses the machine learning. And machine learning can be used not only to detect human faces, but also cat faces, other objects, and so on, because we allow computer to learn about something. So face-api.js uses TensorFlow.js, which is a machine learning written in JavaScript. In this method, we use the pre-trained model, and it's the MTCNN model, so multitask cascaded convolutional neural network. Very complex, very complicated stuff, right? And this MTCNN provides us 5-point face landmarks, so we get the position of our eyes, of nose and mouth. And also, this face-api.js has other models built in. And for example, if you want to use this approach, this method for mobile applications, I suggest you to go with 6-8-point face landmark detection, because it's very tiny and mobile friendly. But let's go back to the MTCNN. So the MTCNN is different from normal neural network usage detection, because it uses free network, which provides the outputs from one to another. So here we have the test image. We produce the image pyramid, and this image pyramid is transferred to our neural network. So the first stage is a proposal. So our network makes proposal where the face can be. Then the stage 2 is refinement. So we clear the wrong detections, wrong presumptions, and the stage 3 is output. So we get the final results. And here's the architecture, how it looked like. So we have the first network is a proposal, the second refinement, and the last one output. And this approach gives you better results than using a single neural network. So face-api.js runs entirely on the front-end side. So we can, using the TensorFlow.js, we can do the machine learning. We can use machine learning in browsers. So here to use it, we need to load this MTCNN model, and it's very heavy. So you need to, it's approximately 2 megabytes. So you need to load it once and cache it, and then reuse it over your instances. Then we can grab the results. Is the async API. So here I use the async await feature of JavaScript, and we grab the results, and we can, like in the previous example, draw the rectangle in the place of the face. And the last one, the most interesting in my opinion, is native face detection. So did you know that Chrome, for example, has built-in face detection? And yes, it does. So this approach uses the shape detection API. This API can not only detect faces, but also text and barcodes. And under the hood, it uses the native implementations of detectors. So for example, for Apple device, we'll get VN detect face landmarks request. That's the API for face detection. And for Android, we get the face detection API. This shape detection API is not a standard API. It was introduced by Web Incubator Community Group, which tries to add new features to the browsers, which are not currently a standard, but maybe in the future. So I mentioned about Chrome. The other browser which allows you to use native shape detection is Firefox, but still Chrome and Firefox allows you to do it only when you enable is using the flag. So in Chrome 69 plus, that's the version of browser that I tested. You need to go to enable this shape detection API because it's an experimental API. You need to go to the flags, the Chrome flags, enable the experimental web platform features, reload your browser, and you will get access to face detector interface. And then how we can use it in our browser is also the entirely front-end technology. So we create an instance of our detector, and as it's the async API, we get the results and we can, for example, draw a rectangle. So to see how they perform these methods of face detection, I created a simple benchmark, which consists of 2 tests. And the first one is the single image face detection. So I uploaded 10 images with different faces, and I measured the elapsed time of the detection. So here you can, as you can see here, you can change the detector. For example, compare how the Tracking.js and native performs. And the second test is the frame rate test. So it's the test that allows you to check how performant is the face detection in real time. One note here, beside my weird face, the frame rate here is a bit low because I recorded it. So if you launch it on your computers, probably you will get the better results. And what is the benchmark without any charts? So I prepared 2 of them. The first chart shows you how well perform each of the or how many faces detected each of the methods, each of the APIs. And as you can see, native and OpenCV are the best here. But in detection time, still the face API can look like the worst solution here, but it's not true. Here we have the chart of elapsed time. So as you can see, the face API was at the last place, but I must say that the machine learning has a potential here because try to, when you will go to this benchmark which is available online, try to use the face API and tilt your head a bit or rotate it, and you will see that all other detectors will fail, but face-api.js will still detect your face. And there's also a second, thought that came to my mind after I did this benchmark is the problem of the good machine. So you need to have a good machine if you both on the front end and the back end side when you use the Node.js and OpenCV, because first of all you need to have a good server, for example, which will process these images, and also you need to you need to have a good machine on the front end side to receive these results and render them in real time. So comparing to the front end methods like the face-api.js and Tracking.js, the OpenCV may be the worst solution here. So if you liked this topic and you want to know more about it, as it's quite complex, I suggest you to take a look at those links. These links, they are very, very interesting and shows you other shows you more. You can learn more about face detection from them. here's the second slide with a list of links. And the last thing, so the face detection and face recognition, like I said, are very, very complex. So even the best players like Apple has problems with it. So don't be upset. Just keep trying to make it work, right? Here are my socials. If you want to ask me a question, you can do it also using our platform, this Slido/Warsaw microConf, or after the talk. And if anything, if you want to ask a question even after the meetup, just use our Twitter hashtag. And that's all. Thank you.
Questions for you. You need to use that server. Okay, I have two upvoted questions for you, Mirek. So the first one is, are there any differences of how native face detection works across platforms like Windows, Mac OS, and other platforms, maybe Linux?
Okay, so yeah, so the three solutions that I presented, the OpenCV plus Node.js and Tracking.js and face-api.js, they only require a good machine, right? They don't care about your OS. But for example, the native detection seems to be very, very nice and very easy to use. It requires it may differ on different platforms, on different OS. So, for example, the Android face detection may behave a bit different than face detection on Apple devices. And also, I read some article where the author says that he tried this native face detection and it didn't work well on Windows, unfortunately on Windows devices. So it depends.
I love the answer. I have another question for you. Can you think of any useful application that you can use these APIs for?
Besides making Snapchat on the front end. So yeah, so the face detection can be used for the entertaining. So for example, if you want to make a very nice, something like AR experience, or maybe if you, I have one idea, so to make an application which put a mask on your face, for example. Because the face detection, like I said, is the first step in face recognition. So if you want to do anything more complex, or if you want to make a face recognition on your front end, you need to go through the face detection. So still, if there is no serious idea for using face detection on front end, still you need to know how to do it. Because eventually you will need to make it work for face recognition.
Okay, and the last question is connected with performance, and somebody would like to know, have you checked performance on mobile, and what are in general the possible bottlenecks of face detection on front end?
Okay, nope, I didn't check it on mobile. I guess that it will not work that well. I checked it on my machine, on my computer, and it worked pretty well. So, what are the possible bottlenecks of this face detection on front end? I think that it may be image processing. And also grabbing, if you want to have real-time face detection, so using your webcam, you need to also remember about the performance impact that is caused by processing the video. So you need to grab this video and you need to process it to prepare it for face detection, which you need to do ideally in 60 FPS, so in 16 milliseconds. And you also, if you have more complex application, using this in these 16 milliseconds, you need to do other stuff. So probably, maybe front end is not ready for face detection, but still I see it as a very promising technology, and it will be very, very nice to have it on the front end, especially that if you use it entirely on the front end, you can, for example, use it offline. So that's the trade-off.
Okay. Thank you very much. Unless somebody else wants to ask a question directly. Okay, cool. Can you come up here? Because that's a wired microphone, so I can't come to you. Okay, you can say the question. I'll repeat it. Okay.
Okay. Is it any possible to use this face detection as an authorization method?
Is it possible to use face detection as authorization method?
Not face detection, but face recognition. Face recognition, yeah. It's possible to do it because we have quite good machine learning right on the front end right now using the TensorFlow.js. Maybe it's not that performant comparing to the Python application, but still we can use it here on the front end. So yes, but still I would go for the backend application for face recognition, because I think it's more reliable. Yeah, but yeah, if you want to make your application to authorize it using the face, it's possible. Just do it, for example, using face-api.js.
Okay. Anything else? Okay, cool. Thank you very much, Mirek, again. It was a great talk.